Hey Ryan, welcome to the first episode of the Token Economy podcast. Welcome.
Hey, Shar. Thanks for having me.
Yeah, totally. Let's get right into it. So, why don't we just get started with you? Why don't you introduce yourself and Val's AI and what you all are up to for people who don't know you?
Yep, great. So I'm Ryan. I'm one of the two co-founders of Val's AI, and we benchmark language models on real-world tasks. So you've probably seen conventional benchmarks on seeing whether models can answer grade school math questions. We're trying to see how well they can support lawyers or doctors or people in finance. We're 12 people today, based in San Francisco, and working with all the major foundation model labs.
Very interesting. So before we go into Val's and how you came up with the idea and the million things that are happening in the AI world, let's take it all the way back. Like, where do you grow up? What was Ryan like as a child?
Yeah. Yeah. Well, I grew up in the Seattle area. I was like just outside of the sphere of Microsoft in Redmond, and yeah, I mean, I think I had a fantastic childhood, to be honest. My parents grew up in a pretty intense households, and so they kind of negated that for me, and uh, honestly wanted me to just play sports and have a good time, and weren't super overbearing, which I'm pretty thankful for. I think there was a part of me that wanted to do more than what I had around me, and so I was eager to do more in school and pretty much more in everything that I was spending time in. And one component of my high school experience that I think was pretty defining is I was surprised to learn how many people in the U.S. didn't believe in climate change, like something that seems so fundamental. And so my belief at the time was that if more people had a sense of the scientific process, that they would understand climate change. And so I took a summer to build a video game to teach kids about climate change, and that was surprisingly effective. So went across the state and basically taught kids through this like Sim Cities type game. And I think that's probably one of the main reasons I got into Stanford, and they saw something that I was taking a real problem and trying to solve it. But yeah, then through college, I was mostly interested in doing a PhD. So I did research with Andrew Ng and Chelsea Finn and Michael Kokendorfer, and that was sort of the plan. So published a bunch of papers, and including one in Nature, one in Patterns. But I also had the chance to work at Microsoft for a few summers, work at Palantir, work at a few startups. So had a smattering of other experiences that informed what I was going to think about doing post grad.
Cool. So talk to me a little bit about what that experience in working at Andrew Ng's lab was like, and how did you really even end up getting into AI?
Yeah, I would say, by the way, that experience of joining Andrew Ng's lab was pretty random. I had spent the previous summer working at Microsoft, and BERT had just come out. So people who don't know BERT, this was a pretty big breakthrough showing that like a single algorithmic development would result in state-of-the-art performance across a wide breadth of tasks people had been trying to optimize for individually. And so I didn't know much about AI models or NLP, but I took Chris Manning's 224 class, watched it on YouTube, and through that was encountered a data set called the Stanford Question Answering Dataset, or SQUAD.
Yeah.
And so I came to Stanford very excited and emailed the lead author of that paper, Pranav Rajpukar, saying, "Oh, I saw what you've done in the squad, and we'd love to get lunch with you." And so we had lunch, and I guess he saw something in my approach to the paper, what I was working on, that he said I could join his lab. So that was my entryway to the AI for Healthcare Research Lab. And I would say initially I was very low ego, working on very simple tasks. Everyone was older, smarter, more experienced than me. So it was just doing a lot of data cleaning and processing and stuff like that. But it was good exposure to join those reading group sessions and do research for the first time. And of course, get to interact with a legend like Andrew.
That makes a lot of sense. So Val's feels like a pretty non-consensus idea. How do you come across benchmarking first, and then just the idea for Val's?
Yeah, yeah. Well, I mean, non-consensus is, I think, maybe another way of saying that it's contrarian. So I would consider that a compliment.
It is.
Contrarian and right I would hope to be the case. I mean, I took a very naive approach to company starting after we graduated. So it was a friend of mine, Lanks, and I. We knew that there was alpha everywhere, and so we decided to put PhD plans on pause. Lanks was going to go work at HRT. We wanted to see if we could come up with an idea where we were differentiated to try and address. And so we took like I said, very naive path of looking at the research papers I'd published and seeing if any of them could turn into a company. And thought process was this worked for Google. Maybe we could give it a shot as well. And so it was actually the second paper that we were playing around with, where I'd built a new evaluation metric in a healthcare context, and we noticed the existing benchmarks people were reporting in these model cards, they were really inadequate compared to where we thought the models were going to be used. Right? It's actually not very important to see can they solve grade school math problems or these esoteric PhD problems in this very abstract concept of intelligence if they don't have the practical intelligence of helping lawyers, helping doctors, people who actually are looking to adopt the models for their day-to-day work. So yeah, that was the kind of genesis. So we saw this delta and wanted to build benchmarks. I'd say, frankly, didn't know what the business model was going to look like, but we've surprised even ourselves there over the last year.
And you started Valve right out of college. Clearly, you were doing AI research and you had a bunch of these ideas. But what actually gave you the confidence as like somebody who was right out of school to actually start a company? Because I feel like you talk to so many students in the valley and kind of across the nation, I'm sure. And the question always is, how do you get enough conviction to take that jump?
I mean, I think it was just hubris, to be honest. Like, to also, I think a certain level of arrogance. Like, I think I've been humbled through this journey so far. But I came out of undergrad having worked at Palantir, where there's some of the best engineers in the world, and feeling that I could solve any technical problem that came my way. Some of the work I did at Palantir went on to be, deployed in a pretty significant context, and actually recently found out that a little 1 week project that I worked on is getting patented. So they took it to the limit. It was just a side idea that I had, and so it gave me the impression that I could always sort of go back to Palantir. What I encountered when I was meeting with some of the senior leadership while I was there is that those people in my shoes wouldn't join Palantir, or their risk profile didn't show that they would, and instead they would go on to start Palantir. So if something like ChatGPT, a real black swan event was happening, and there's something new that we could take advantage of, why not us give ourselves the opportunity to try? And I'd say definitely lost a lot of brain cells along the way and been learning, but a decision I don't regret in retrospect.
And you talked about how you surprise yourself with the business model too, as like you really wanted to build benchmarks. I guess, how do you think about Valves as a company? Do you think yourself as a benchmarking company? Do you think yourself as more of an infrastructure company? Like, how do you even position yourself across the stack? Because it feels like there are so many different ways in which you could take this.
Yeah, I mean, I think benchmarks and evals are pretty well understood as a mechanism to drive model improvement. Like, if you don't know how well your model's performing, what do you improve on? And if you have the signal, you can actually drive model performance and train them in a certain way. But actually, I think where we have a lot of value is in evaluations as a go-to-market motion. You have sellers or people who are investing billions of dollars to build models, but struggling to really convince people of the net new value of these models. And then you have buyers on the other side who have a lot of top-down mandate to adopt AI, but paradoxically, not a lot of technical acumen to actually figure out which models or products they should be using. And so I think we're in a pretty unique place where we can bridge that gap. We can help facilitate transactions of AI because we are, newly exposing the quality of models and tools that are on the market.
So who ends up even being the customer? So does the customer end up being Frontier Model Labs, or does it end up being kind of the core customer, which is any of these enterprises?
I mean, I think in the limit, it's probably people on both sides, and you see this model in other industries as well, where market intermediaries are able to capture value on both sides. Today, we have found that foundation model labs are moving very quickly and are initially the lion's share of our revenue, but I don't think that's going to be the case long term.
Yeah, that makes sense. And I guess zooming out a little bit, it feels like evals and benchmarks were really driving so much of the model improvement, and really dollars and efforts that all the large labs were putting their minds to. And I guess in the valley it was called benchmaxing, which is you basically take a benchmark and you take it to the limit of like, can you come out saying, hey, like, whatever, Claude Opus is better than all of these others on this benchmark. But now, of course, like, it feels like we're shifting away from just benchmarking to real world applications. I guess, as somebody who's kind of at the epicenter of this, of benchmarking, but along with that also, what does the real world applicability look like? How do you think things have evolved in terms of where people are spending their time and dollars at these frontier model labs?
Yeah, I mean, I think the reality is that in most of research history in NLP, the investment in generation and evaluation systems has been coupled, and it's gone hand in hand. One has led to the improvement in the other. like for instance, you start with regex checkers, but then once you want to do machine translation between say English and French, then you need a new metric, something like blue, to measure that. And then you want to do more complex question answering, you use BERT score, and then now we have more complex things like LMS judge. And so I think on the whole, what you've seen is that the level of investment in foundation model labs on the generation systems has led to a pace of development that has not been kept up by academia on evaluation systems. And so there's a big room for us to actually invest in techniques for evaluation and data sets and actual benchmarks that go into measuring the capability of these generation systems. And so I think labs internally have done a lot of work in this, and that's what's driven improvements. But it means that they have first party results, which don't make a lot of value for the landscape at large. And we can actually do something in a neutral third party way to communicate whether these models are good or bad.
Yeah, and how do you think about kind of productizing so much of this intelligence? Because it feels like the amount of intelligence we've created is really massive. But then if you go talk to real enterprises, the amount of AI products that they're actually using is still, I mean, some people are not even using ChatGPT. I guess, like, how do you actually end up measuring the real world impact that these enterprises are having? And what are you seeing in terms of changes from the labs to actually maximize more of the returns from, I guess, maximize more of the impact that the intelligence is creating?
Yeah, I mean that is a really tricky part of this whole equation. A little anecdote, but I met with a director of AI at one of the very large banks, and I was trying to ask him, "Are you using Rogo? Or using Hebia? Like which of these tools are you using?" And he says, "Oh, I have someone that's trying those things, but actually, I'm much more excited. We just managed to deploy Copilot across our whole bank. It only took me 18 months." To get this done, and so he was quite, pretty proud of that. But I think the lesson being that in a lot of these enterprises, they will go to the bundled solution as opposed to some new product experience that they're being pitched on. And that may change. Maybe we just have to give the market more time. But I think there's something to a behavior or a product experience that people are already familiar with, which has AI bundled into it. And I think also at the end of the day, what will drive a lot of adoption is client demand or efficiency demand to keep up with the market. Like you see this, I think, in legal, where there's mandate from the clients to be an AI law firm, to be using AI wherever possible, so that the dollars spent are spent in the most efficient way. And so I think once you take a turn in that direction, there's a lot more of an internal impetus to use and adopt AI.
Yeah, and as somebody who thinks about kind of these verticals, you were mentioning you built this healthcare evals benchmark, and then kind of a bunch of different other verticals, which I'm sure you're targeting. How do you think about kind of the application layer companies, which are of course taking the base model and then kind of building something on top of it, versus the base model versus of course the frontier model companies? And I feel like finance is a great example here, because it's clear that almost every frontier lab cares about finance and cares about coding. I guess those are two verticals we can take. And but then of course there are these wrapper companies, or you can call them wrapper, you can call them companies building on top of these models. How do you think about the competition between them? And do you think, and why do you think some of the application layer companies like the Cursors of the world and the Harveys of the world have been able to break out from these frontier labs?
Yeah, it's an excellent question. I think one which a lot of companies will have to reckon with, especially over the next year. But I think Cursor is a little bit of a different type of company in the application layer. And just to draw it out, I think it's because they have their own model. And they've reached the point where they can largely be independent of foundation model labs. Hypothetically, if labs cut off their access to their models, I think Cursor would still be a very valuable company. And they've established a large user base and data flywheel so they can continue to make this model better. And so I think if that's a sign for what's to come, there's a little bit of a race for seeing if foundation model labs can build an intuitive enough product interface that has the distribution before or after application layer companies who have already earned the right to exist with a large customer base can get into their own foundation model labs and effectively sever the tie between them and the labs. And I think in the places where the foundation model labs are actually able to build that product interface first, it's very unclear what the lasting power will be of the application layer companies. And I would actually just expect in the long term, there are not going to be that many companies who have frontier intelligence in the domains that they're selling into. Like I think it's actually going to be, but I would expect fewer than there are today. We've been wrong. I've been wrong about that in the past, and there's actually way more foundation model labs and application layer companies today than there ever have been. But But I just think in the long term, the cost to build these systems will be so prohibitive, and the groups that already have distribution will be the ones that can build a data moat around their application.
Yeah, and you mentioned a bunch of the fact that you've been wrong about the fact that like there will be less labs, and I think that is certainly true. I think at some point people are even expecting a consolidation of the lab versus what we've seen is actually the exact opposite, which is we've seen more neo labs, and those neo labs have consistently raised increasing amounts of dollars.
I mean,
What have you?
maybe I'll actually ask this of you, Sharia. So, I mean, I predicted that over 2025 we would see fewer foundation model labs and fewer models. And the thought process was that it's very capital intensive to start a new lab. And so, yeah, right. If anything, we'd see consolidation. But also, more than that, models were getting strictly better. Like, there's almost like semiconductors where they're getting more efficient, meaning more intelligent, cheaper, faster, more capable. And I was wrong on both counts. I think I didn't anticipate how much VCs were willing to underwrite new labs and this incredible talent that was being concentrated in these new places. And I didn't anticipate reasoning models where you could actually have a trade-off between latency, cost, and capability and quality, which has now led to, I think, compounding set of options. Obviously, very good for us. There's a lot of things we're testing keep us up late. But I'm curious if you think this trend is going to continue, whether investors will continue to be able to underwrite new foundation model labs being built.
No, totally. And I think it's an interesting question and one that I think pretty actively about. I think there are a couple of different kinds of neo labs, right? Like one, I think is there are some vertical domains which are so strictly expert driven that you're going to have to train your own model in order to do so. And the argument there is the fact that none of the large labs are going to be, because this is so specialized, are going to focus on this, but you need to own the weights of the model in order to truly build something that is intelligent enough to produce higher ROI. And I think there it makes a lot of sense. And the other place I think it makes sense to have a large lab is there is also going to be this productization of of these base models, but along with that there is a fair amount of technical work to be done to actually deploy them in some of these domains and even deploy them in the enterprise really. And I think there is this misnomer around if you call yourself a lab, you're strictly going to be doing research. And I think some of these labs are very FDE driven, where they have this forward deployed engineering motion where they literally take so much of the intelligence that they'll take the open source models and they'll do a lot of the RL technical work in and around it in order to build something that is very custom made. And I think there's a fair amount of potential there. So I think like yet to be seen what the success of some of these new neo labs looks like. What I will say is that the dollars are getting very large and the valuations are getting very high. And the question always ends up being how big of an outcome as an investor do you need to underwrite in order to invest in any of these? And like if you raise at a couple $1 billion, you have to underwrite a pretty massive outcome. And I think what makes these bets riskier is the fact that so many of these end up being research bets. And I think investors are certainly more hesitant to take research risk at very high valuations versus take more execution risk. And yet to be seen how some of these things pan out. I think one of the things that I'm pretty excited about is the applications of AI in science and math, and really like in breakthroughs that will happen. And I believe some of this stuff is probably in the near term. And if that is true, then there are probably pretty massive companies to be built. But I assume that there is a certain slice of investors who are willing to take that risk, and the majority are probably for large dollars at high valuations are still probably a little hesitant.
Okay, yeah. I mean, I guess I will say I'm glad that people are continuing to make these high variance bets. I was quoted in this New York Times piece, I guess taking the counterpoint to Jan LeCun's rationale behind starting a new company. And never a good idea to be a vocal critic of a godfather of AI. But I was trying to make a more defensive point that LMs actually are very capable, and I think there's a well understood process by which we can make them more capable. So much so that we probably don't need these high variance bets for them to have tangible value. But I am glad, like as a counterpoint, I am glad that people are giving Jan LeCun and Ilya lots of money to try experiments, because I think it's quite unique about, I think, the American capital structure system that we can actually take big risks and potentially see big rewards as a result.
No, totally. That I agree, and I think if the promise of AI and if the returns on AI are as big as the promise, then there's a pretty good chance that many, and even if a small handful of these bets end up paying off, the fact that the amount of impact in the world could be pretty massive. One of the things that is kind of the top of mind for so many founders of the valley is reinforcement learning and the impacts of reinforcement learning on making some of these models smarter. And as somebody who is benchmarking many of these more verticalized solutions, what are your thoughts on reinforcement learning as a technique, how people are utilizing it today?
Yeah, I mean, I think reinforcement learning is everywhere. I think maybe a more precise question that I see is, do we think that improvements will happen from reinforcement learning happening at foundation model labs, or in some more specific capacity on open source models that are going to be deployed? Because, like, make no mistake, there is reinforcement learning happening in post-training teams at every foundation model lab, and they have a pretty close relationship with the big customers that are using them, right? And so if they find failure modes, they will improve the underlying model, and usually that has crossover effects into other users and applications that will take advantage of that. So I think, like, there's probably just two worldviews that feel on extreme ends of the spectrum, but you have these sort of God models, which continue to be used and adopted in very disparate ways, that continue to see tight feedback loops with researchers at the labs and get better. And then maybe you have the more specific intelligence view of the world, where maybe labs will slow down, or they won't actually care as much about some of these niche use cases, or they'll have to prioritize. Actually, improvements in one area will come at the cost of others. And so for those reasons, you would expect more specific intelligence models, a la applied compute or thinking machines, and folks like that. I mean, I think fortunate for us, our job is important in either situation. I think so long as there's not a single God intelligence that use everywhere all the time, is there's no optimization process that has to happen. There'll be interesting things for us to test and evaluate. But I think they are pretty different views of the world, and the diplomatic view is, or as you might say, the procedural view that I'll put forth is that it'll be a mix of both, and that there will be some domains which don't get as much appreciation from labs, and specific intelligence is I think the only path to have high performing tools, and then others, I think, where you're cost or latency constrained, and then again, having some smaller open source model RL fine tuned to be applied is a necessity.
Yeah. And you talk to a bunch of these enterprises as a part of the go to market motion for some of the customers that you have. What has been the what percentage of the enterprises, or just what is your sense in terms of how many of them are actually using open source models versus closed source models? And what do you think? And do you think that shift is going to happen in the near term, or do you think that's much further away and people are much more focused on intelligence versus the actual cost? Because of course the open source model lag the closed source ones.
Yeah, I mean, I think it is quite different between verticals, but I'd say, just as a sweeping statement, I think people would be surprised to see how little open source adoption there is happening in some of the verticals like legal, finance, healthcare. It's potentially because the sales teams in the closed source labs are just so good at pounding all the doors and getting the models in, and there's now a lot of consumer trust that's been built up by using these tools over time. Um, but I think there are some cases where, sorry, it's too many late nights in startup world starting to get on me. But yeah, I think particularly in like the banking field and places where they have been so intent on keeping on-prem compute and running models locally, where there's still need for open source models. I think there's also a little bit of an unfortunate paradox right now, where the best open source models are actually all Chinese models. Last week we had Kimi 2.5 come out. It's actually better than closed source models in some use cases. And so I think there's a lot of enterprise uncertainty as to whether or not we can actually trust those models to be used in places where we don't know exactly to what values they've been post trained.
And what do you think makes some of the labs better than the others? Because, like you mentioned, like most of the open source models are Chinese versus the closed source models, which are at the frontier, are of course American. But then even amongst the closed source models, there are a handful of companies that are spending a lot more money on training than the others. Versus, and I think a great example is probably Anthropic with coding, which is Anthropic has clearly been far more efficient than OpenAI and some of the other labs. Why do you think that is, and what do you think differentiates Anthropic's approach from OpenAI, and even and the approach of the Chinese open source models? And what do you think makes any of them better at some of these at model training?
Yeah, I mean, I think it's. I'm also going to try and uh, not say anything too sensitive about our like interaction to the labs, and but I think if you look at the even external messaging of the labs, it's pretty different, right? In the way they position themselves and their priorities, and so I think you could probably take cues from that to figure out why do certain labs spend time on certain problems over others. And so if you just look at the words Dario is saying and the focus that he's laid out for the company, I think he's very clear. And like it's not dubious for people in the company what they're prioritizing and what they should be working on at any given time. Whereas so I think some of the other labs, there's inherent confusion as to what the biggest priority is and like what they're okay being second place in and what they're not. And these things may change very, very, very quickly. I think that probably lends itself to an efficiency of the team that you see borne out in the performance of models. I think what's going on in China is also just can be categorically different. Like we talked a lot about research and new labs getting formed in America, but I think the most interesting papers I've seen are coming out of China. So if research is a function of papers published, there's a lot of good research happening in China, and so I think there are people who are often resource constrained just in the number of GPUs that they have, and it forces them to make new innovations at kernel optimizations or an underlying architecture, which I think amount to more interesting models that are produced.
Yeah, and you bring up the point of compute, which is of course very interesting because it feels like we're in the. I mean, we most definitely are in the biggest infrastructure build out of our lifetimes. Clearly, with OpenAI's commitments, they have showcased that compute is the big bottleneck. How do you think about compute and efficiency, and what are your views on how much infrastructure and compute we are going to need over the next 5 years, and if there are going to be any efficiency gains?
Yeah, I mean, I think this is really tough to reconcile. I mean, I think the other part is we've had a engineer who, at the start of the year, uh, came to work with a Mac Mini, and very proudly said that he was by the end of the year going to automate his job with the Mac Mini, and so it's not going very well, unfortunately. Still have to hire engineers, and they can't automate themselves out of a job, but. And actually, the other interesting thing is he's recently switched from using locally running models to actually just using Codex and Claude Code and stuff like that. So, I was going to basically say, if the future of the world is everyone can have their own Mac Mini that's automating their work, then there's not that much compute needed, right? We could probably make enough Mac Minis for everyone to have that level of compute on their desk. But I think if you think that we're going to have this continued dependency on Codex, Claude Code, these basically data centers continuing to run, then just to serve inference, not even talking about training, we're going to need so much more compute, right? Um, and then I think then if you view scaling laws and see that actually we want to keep seeing intelligence improvement by scaling the amount of training we can do, then yeah, I think we're going to see continued investment and demand for any kind of compute that people can get their hands on.
Yeah, and I want to keep digging deeper into this infrastructure topic. But as a side note, Cloud Code has clearly taken off completely. Why do you think that is? Because it felt like 6 months ago, cursor was the only thing that people could talk about, and then of course Cloud Code has really picked up, and now OpenAI has showcased immense amount of focus on Codex. What do you think is making Cloud Code just break out a breakout success?
Yeah, I think there's a lot of basic answers you could give around capability of the tool. I think developers talked a lot about the level of its abstraction, like the intuitive design to it, and there's probably something about the post-training team sitting right next to the people building the product. They can exchange prompts and instructions to build an effective tool. Actually, I think the answer I'd give is a little bit different. I think what they've done very well is captured in parallel ways a technical and non-technical audience. So, 6 months, 9 months ago, there was vibe coding tools like Lovable and Bolt, and then there were developer-focused tools like Cursor and Windsurf and things like that. And I think Claude Code has somehow managed to do both. Like engineers love this tool. It's a CLI, and the best engineers only work in the CLI, and so they understand the interface very well. But then non-technical users have a pretty friendly experience of effectively coding for the first time. And so I've had friends come to me and say, "Oh, I built this myself, myself with Claude," and so that's a new experience that they can have for the first time through this chatbot type thing that they're starting to be familiar with. And so I think that has lent itself to a much larger audience of people who've bought in and felt love for the product.
Yeah, and one of the things I've been thinking a lot about is like, do you think this is like in so many unexpected ways? Do you think AI enables so many more people to be entrepreneurs and founders? People who before this were using I don't know, Wix or one of these website builders in order to start their own consulting firms or any of these small businesses. Do you think this could be the moment where the renaissance of a new crop of founders restarts?
I mean, that's a very optimistic take. So yeah, maybe you want to get behind that. I mean, you're seeing that with Moldbook and stuff like that, right? There's this a spur of open source projects which are getting a lot more attention, and uh, anyone can really contribute to. I think the potential pessimistic take would be though that it takes more capital and resources than ever to do something really impactful, and so potentially, like for instance. If you have a more cynical take would be if you have a person, they can actually address their legal issues themselves. They can call a language model and potentially resolve legal disputes without hiring a lawyer, something so super expensive. But you could also potentially have a lawyer who's able to pay for a much more expensive AI model, or like a higher reasoning model that is able to just win more negotiations, win more disputes, and kind of overpower the plebeian models that everyone else is using. And so I think it's still pretty unclear to me whether AI is this tool which will empower a large base of people to be more productive, be more capable, and advance in the socioeconomic system, or it's something which will on net just benefit people who are already wealthy, well positioned to kind of further the position that they already have.
Yeah, yeah. And on the topic of AI agents, and it feels like everything is becoming agentic. One, how do you think about evaluations for AI agents? Because that ends up being somewhat different from what from what it looked like just 12 months before of how people are consuming AI. And how do you think the data flywheel that you've talked about for some of these frontier models and how they're making the models better? How does that fit into the entire picture?
Yeah, I think about a year ago, this was a very open question, what agent valuations look like. I think now there's a bunch of different working hypotheses, and I'll share ours. So the way we view it at Vals is really we're doing outcome-based evaluation with some cost function. So you can view the agent as some system which can call tools, take a bunch of turns, and then finally make a submission or reach state of the world. And we first order care about whether that state of the world is correct and accurate. And then, conditioned on that, what is the lowest cost or latency that we can see in reaching that outcome? And so those and that kind of Pareto plot, you care really about what's on the Pareto curve. And then I think once you have that, you can dig into more of the actual trace and figure out what the model did along the way to arrive at that outcome, mostly as an error mode analysis or a way to debug what's going wrong. And so there's actually a great tool out there by Transluce called Docent, which lets you basically dump a bunch of these traces into another language model and figure out what went wrong or what worked, what was the behavior of the model itself. And so I think that is sort of the approach people are taking to building benchmarks, evaluating, and then iterating on a lot of these agent workflows. And the other question was,
On the data flywheel and how big of an impact, or I guess what is so unique about some of the data that some of the labs are collecting, and how that translates into these AI agents becoming better?
yeah, I guess you're really incented to see as much of the real world problem as possible to iterate. Like if you can see this rollout and see, oh, it's making 5 web search tools that it could have actually just made 2, then that's kind of the reward signal that you want to make the model as efficient as possible. Or in the other case where it's just not producing anything of substance, you can use expert traces or kind of like the guidance of someone who successfully completed the task to inform the model how it should behave.
Yeah, and it feels like, I mean, like, of course, like ChatGPT was created by scraping the entire web, and now we're going down this rabbit hole of what you were mentioning, which is take these experts and basically get these expert traces, which is not very cost efficient, then the question ends up being of synthetic data. And like, is there a path for models to actually end up using synthetic data, or do you think it all ends up, or I guess in the short term the focus is going to be on expert traces, and along with that just on distribution, which is if you can get your product in the hands of lots of customers, you can collect lots more data and then make your model a lot smarter.
Yeah. By the way, just to clarify, I don't think ChatGPT was trained on the whole internet, right? Like even ChatGPT, as we know it today, had pre-training and training on the internet as one portion of it, but has also had significant breakthroughs in post-training and that RLHF process to build a chatbot we can actually interact with. So like that, I think not to be underrated in what that process entails as well. I guess your question is like, where do we see continued improvement from here, and do we have to take new approaches to get there? I actually think what's most exciting right now is data efficient approaches. And so I think this is becoming a lot more common. Actually, you could talk to our friends at Flappy Airplanes about this, because I think this is what they're looking at. But seeing what if you could train equivalently good models with much less data, and that would be very interesting because for a model to learn new skills, it would similarly it wouldn't need that many examples to be able to reach expert level. So potentially you're a banker, or you're trying to upload this podcast and edit it. But don't want to have to give thousands of examples. You just show one successful example, and then it should figure out how to do it. So I think there's exciting, and actually, if you look at some of the DeepSeek papers, this is what they're kind of able to show as well. I think if you're looking for novel research directions, it's probably in data efficiency where we can see big breakthroughs.
That makes a lot of sense. I have two more questions for you. One is which is the question where all of this started, which is how do you define AGI? Because as an evals company, I'm sure lots of people ask you, which is the definition of AGI feels like it changes. Everybody has their own definition. How does Vals and you define AGI, and do you think we're close?
Yeah. Yeah, well, if you're watching this and interviewing for Vals, this is a question I ask of every candidate. So I've heard lots of responses. Yeah, I mean, I think to me, AGI is like pretty poorly defined, and so I've written a bit of a blog post where I think if you look at the constituent parts, you should view AGI as an index, not as a binary. And so we should speak in the form of this model expresses a greater degree of intelligence on greater spread of tasks that make it more general. Or you could say selectively, it's more intelligent for a subset of tasks, but it doesn't exhibit as much generality. But to say this is AGI is akin to saying this child has height, right? Its height is a continuous measurement. And so I think what's actually far more interesting for me to measure is something which a lot of people have talked about, Nick Bosterman in particular, is human level machine intelligence. When is it that a machine is capable of reaching parity with humans? And I think that's really valuable because then you can see automation or efficiency gain thanks to using AI. And I suspect that a lot of the economy today, probably we have HLMI. It's mostly an adoption challenge for why we haven't seen the ROI in the investment and foundation model labs.
And do you include the physical aspect, because like so much of the economy is construction and real world tasks?
Definitely. Yeah, I would consider the physical world as well. I think, but like we do have Waymo type systems. Like I think in truck driving, it's one of the most popular jobs in America, and probably could be automated within the next couple of years, so very very soon. I think a necessary part of the definition also with HLMI is that it changes, and so it's possible that the work that people are doing in the next 2 years will change, and so where we see the automation in the economy and need to see models continue to improve will change as well.
Yeah, makes sense. Last question, which is, uh, and this is, I guess I'm going to ask this to every guest, which is, so what's your wild prediction for the year?
Oh, that's a good one. Yeah. Well, okay, so this is kind of topical. We just released a benchmark last week called Proof Bench, where we're seeing whether models can solve these really challenging graduate level math proofs. And the first time we're really able to assess the proving process as opposed to just the final answer, because we're using a language called Lean, which is verifiable. And what we see is that currently the state of the art foundation model is getting about 36%. There's a tool by a company called Aristotle, which the tool is called Harmonic, and it's or actually, sorry, flip that. It's Aristotle by Harmonic, and it's getting around 70%. So I'm pretty optimistic seeing these results. I think by the end of the year, we should expect to see some breakthrough in math. That's either coming from Foundation Model Lab or one of these math research groups like Harmonic or maybe Axiom.
Awesome. Ryan, this was so much fun. We should totally do this again. Thank you so much for coming on.
Thanks for having me, Shari. This is fun. Feels like a continuation of a regular Tuesday night.
I know. I know. Awesome. Thank you.